Let me just make sure. Cool. And then we will go into some questions that were shared with me. So again, if you have any that you want to send to me tonight that we can work through tomorrow, please do that as well. Then we can still tomorrow look at some questions as well. Okay, so this is just a bunch of questions, so there's no particular order or anything of it. So let's get into it. Okay, so the first one that we look at here is we get information that says previous experience has indicated that on average customers of a local pet store spend 550 per purchase with a standard deviation of 75. We talk here about the sample, and assuming a normal distribution, what is the probability that the mean value of the purchases in the sample is more than 555? Okay, so let's start off with writing first the formula down. So the probability more than, so bigger or equal to, so 555 minus 550. So remember that is your x. So that's the formula that we are after. So standard deviation 75. Your sample was 105. So let's see, probability of Z bigger than that. Okay, where's my calculator? Okay, so 555 minus 550. Okay, so at the top, let me just. At the top, we've got 5. Then 75 divided by the square root of 105. Okay, let me just try that again because my calculator didn't. 75 divided by 105. So I get, sure, let's hope this is right. Get that as 7,319. So that will be, looks like a weird number. So let's just hope my calculation was right. 0,68. Okay, so there is, so hopefully that is 0,6831 is correct, but we're looking for the probability. So on our normal distribution, so where it is 0,68, we want bigger, so we want more than, so we want this component. So if I look at just quick answers, if that is 0,5 for this area, we know that that area will be less than 0,5. So already we can eliminate A and E. So let's go to the Z table, minus 0,68 to get the smallest side on the left-hand side. So let's just see. 0,68, so minus 0,68 minus 0,68 seems like 0,2482, which is the one that we got there. So basically, we need to get and work out the Z, which is 0,68. And let's just quickly 6831. Let's add that, but if we round it off, 0,68, and that's what we're going to look for on the table. Then on the table, 0,68 is 0,2482. Okay, and that is what we were looking for. Okay, so this is the first one, basically looking at, this is study unit 7 that we looked at the probability and then getting the Z value. Then from the Z value, we need to work out what is that area that is more than. Okay, so let's go into another question. This is confidence intervals. So let me also just crop it a bit and then I can crop it more. Okay. So determine a 95% confidence interval for the true proportion. Okay, so when we see proportion, we can already work with the Z. So we can already work with the Z, and because it's 95, we can say Z is 1,96. So our formula would look something and then let's just get this right. 1 minus that over n and the square root. Okay, so they tell us that we are working here with 120 out of 200. So 120 divided by 200 is 0,6. So let's just six, because that is 120 divided by 200. Okay, so we have 0.6, then plus minus 1,96 because of a 95% confidence interval, and then in 0,6, 1 minus 0,6 is 0,4, and that divided by 200. Okay, so we've got 0.6 times 0.4. So that is 0.24 divided by 200 is 0.0012. And if I take the square root of that, so I get 0.6 plus minus 1.96 times 0.0346. Let's multiply that by 1.96. So 0.6 plus minus 0.0679. So the top one is normally the easiest. We just add the two, 0.6679. Maybe it is, and then the bottom one is equal to 0.5321. Okay, so this one, they tell us the proportion. It's 120 out of the 200. Then they tell us we're working with a 95% confidence interval. So because it's 95%, we can assume that your Z is 1.96. So we've got the formula that we can replace everything with values. If we work it out, we get option A as the answer. Okay, so confidence interval of a proportion. So this one was out of study unit, what is it, 8. Okay, and I think the answer was also shared with me how to work it out. So I have added that for you guys as well. Okay, then I was asked to look at this one. So again, something that is definitely likely to be part of something that you guys might get. So let's first. So we need to find that value. So what they're giving us is that you're looking at the probability Z smaller than 0 and bigger than something else. So this area must be equal to 0.4803. Okay, so we don't know what that answer is. But just by looking at these answers, that must be something that is negative. So if I look at these answers, the only one that's negative is option 2. Okay, but we are going to also work this out. But just again, we're looking for a probability where Z is smaller than 0. So we can't have a probability where Z is smaller than 0 and Z is bigger than 1 or something like that. So it needs to be bigger than a negative because we're looking for the area there that is 0,4803. Okay, so what I would do is I would get this area. And then with that information, I will go to the negative table. So how to get this? I would say 0.5 because that's half of it, minus 0,4803. So 0.5 minus 0.4803. So that is 0,0197. Okay, so even that answer creeps through in the answer set. So I'm looking for that probability. So I need to go to the negative Z table and not look for the Z value. I need to go into the probabilities and then find my Z value. So negative table, and I'm looking for 0,0197. So negative table, and I'm looking for 0,0197. 0197. 01. Sure. Why don't I see anything here? 0197. Okay, so there is the 0197, and that is at minus 2 minus 2.06. Okay, so then if I look at it was the minus 2.06. Okay, so we're basically going to look for this small area. The easiest to get to that is by looking at my negative Z table to get to this. So the value I'm looking for is 0,0197. I have seen it there, the 0,0197, and that was the minus 2.06. Okay, but also if you guys are in the exam and you get something like this, and you only have one negative answer, it might be one of those where you then can save a bit of time, because yeah, we know it is quite a lot of questions in the time frame that you guys are writing. So sometimes one just needs that extra bit to get you that extra time and things to save. Okay, so let's go to the next one. Let me first also crop, and so you guys can see, please, if you have more of these things, you can really send it directly to me on WhatsApp. You can send it on the WhatsApp group as well, and I will add it to the session tomorrow so that you guys are prepped for Saturday. Okay, so let's look at this question. So, and we know that you guys are now not allowed to use Excel. Okay, so that we've now established that you're not allowed to use Excel. So let's look at this and see if something like Excel was in actual fact needed. So let's look. Right, tell us here's the data. They give us the sum of X. They give us the sum of Y. Then they say the correlation coefficient is 0,327. Which one of the following is incorrect? Okay, so there is a positive relationship between X and Y. So that is true because that sign in front of the correlation coefficient, it is positive 0,327. So we know there's a positive relationship. This we can work out with that number. So this we don't need Excel for. You can use your calculator. So we know the average is the sum of Y divided by the number. So we've got 35.3, and there is 1, 2, 3, 4, 5, 6, 7 numbers. So 35.3 divided by 7 is equal to 5.043. And so that is correct. Then the coefficient of determination. So coefficient of determination is R square. So we will need to work that out, but that is 0,327 to the power of 2. Let me just, that nearly looks like a standard deviation. Okay, so 0,327, so 0.327 times 0.327. That is actually 0,1069. So coefficient of determination is wrong. So again, we didn't need Excel with the information that they've given us. The regression coefficient B1 is also positive. That is correct because if your correlation coefficient is positive, we know that your regression coefficient is also positive. So there's always that direct link between those two. And then only 10.7% of the variation in Y is explained. Also correct because this is the variation that is explained. And if we multiply that by 100 to get a percentage, we do get 10.7%. Okay, so this is study unit 11. But again, just showing you guys also that there's a reason why you won't have to use Excel, because the questions will not be set up that you actually need Excel. So they will not now have asked you with this information to work out what B1 is, because that will not happen, because that is unfair to you guys. So, but a question like this is extremely likely to be in your exam paper. Okay, so here's another one with answers. Oh, sorry, not with answers, with a question set. Okay, so again, they give you the data, but they give you the information that goes with it. So again, you guys will see now they're not unfair with the information or what they are giving you. So and let's just crop this a bit more that we can. Okay, so here we have the data. They give us B0, they give us B1, and then they ask us questions around it. So, and which one is correct? The relationship between X and Y appears to be linear and positive. Okay, so let's just first write down B0 and that is your y-intercept. Let's just say y-intercept. See, that was the regression coefficient. So B1 is minus 1,257. That's your M or your slope. So that also gives me that I can write this out, because I see we need to do that in any case, as the y-intercept 13,223 minus 1,257 x. Okay, so, and that's probably one of the things that is right or wrong. Okay, so relationship between x and y appears to be linear and positive. Okay, so it's definitely not positive, because your slope is negative. So that's not true. Linear would have meant that as x goes down, y goes down, or y increases, and the other way around. So here you can see also there's definitely not a linear relationship, because there you've got x, 5 and 7, 6 and 5, 3 and 10, 10 and 1. So does not feel like a linear relationship, but it might be if we order it differently. But the thing that is definitely wrong is that it is not positive, it is negative. And so that is incorrect. The least square regression line is y is 13,223. And so that one is correct. The least regression line is, okay, so that one is incorrect. So then if you work with, depending on with which line you would have worked, if x is equal to 2, then that will definitely be not negative 25. But if you had the least regression line 3, that would have been also correct. So that's incorrect. And then an x value of 11 resulted in an estimated. So again, if you say 11, so let's check that one just for interest sake, because it looks that could be correct. So let's just check. So y is equal to 13,223 minus 1,257 times 11. So 1.257 times 11 is 1382. Okay, so no. So that will give us minus 0, 604. That also shows you that option 5 is incorrect. So the correct one for this one is option 2. Okay, so again, if you, and again, I don't know even how my calculator HP works with this, but if you have a calculator and you want to put it in, you can, but it's not in this instance. They give you all the information that you need. So you also don't need to go to put in this even in your calculator, because they give you the y-intercept, they give you the slope. So you can work out all the other things just with that information. Okay, so this was also out of study unit 11. Okay, so let's go to the next one. And let's see what is asked in this one. Okay, so the average number of radios sold per day. Okay, so already, if they didn't tell us Poisson, we could have seen with the per day that it is more than binomial. So, and that average number also means that we're looking at the average for lambda with a mean of 1.2. So we have a lambda as 1.2. The probability that the firm will sell at least. Okay, so at least is again probability that X is bigger or equal to 2. Okay, so at least 2 means minimum that you need to sell is 2. Okay, so this one, we need to go to the Poisson table, lambda 1.2. Let's see where that is. Poisson 1.2, and they want bigger or equal to 2. So we will need to add all of these, or we can say 1 minus 0 and 1. So I would rather say 1 minus. So I would say 1 minus the probability of 0 plus the probability of 1. But you can always do the other way around and add all of them together. But I would just do the minus, so 0,0312. Sorry, 3012 plus 3614, 3614, 3614. Okay, it's interesting that nowhere here any of those two are. And I don't think one of these. Average number of roses. This is interesting. So let's work it out. I don't see one of these as an answer. Hmm. So 1 minus 0.3012 plus 0.3614. No, it doesn't look like I'm getting any of those. So that will be 3374. Hmm. Okay, this is very interesting. Average number of radios sold per day by a firm is with a mean of 1.2. So we've got the mean of 1.2. Probability that the firm will sell at least means 2 or more, so that's fine. Hmm. So even if I look at those breakdowns of those numbers, there's nothing of that in there. Okay, I will go back and check this one. This is weird. Did you guys do this one out of or have any ideas? But I will definitely go back to this one. It's just weird that there's not even any of these numbers in that graph. That's just sometimes there's at least one of the numbers is somewhere in it, but this one was nothing, um, which feels like somewhere um, there was probably a mistake in the whole question. Um, yeah, so let me go and check for you on this one, but this is how we would have worked it out. Okay, so I will just check this one for you guys, and come back to you on this. But this is suppose how you would have worked it out. Okay. Okay, so here again is very similar to one of those previous ones. So here we can again see that they are giving you the information for the straight line. So yes, they give you all the data, but again, we've got B0 and B1. Um, I'm just checking. Okay, so it was exactly the same data that you got, just a different question. So again, you guys can now see. So let's move those two with one another. So it's exactly the same data that was given to you. So they just have a few different options to it. So and this time probably by asking, yeah, the incorrect one. So again, you guys can see the same with the 1610 and the 1510. They do mix up the questions. So some of you might get the previous one that we did. Some of you might get this one. Okay, so let's see. So here they actually ask you the coefficient of determination, the relationship. But what I would do first is work with the things that we know you can work out without going, because again, there's reason why they have given you all of these other things so that you can work with it. Okay, so if x is equal to 2, the estimated value of y is 10,71. So let's work out 13,223 minus 1,257, and that is 2. So if we put 2 in there, 2 times 1.257 is equal to 2,514. And if we subtract that from 13.223, we get 10,71. And so that is correct, but we're looking for the incorrect one. The least square regression line is 13.223 minus 1,257. Then correct, we're looking incorrect. An x value of 7 results in that, so we just need to replace that by 7. So let's do that. So 1,257 times 7 is 8,799. And if we subtract that from 13.223, we get a positive 4,424. Okay. Not negative, but positive. So that's where that one is wrong. So then we don't need to work out the coefficient of determination. So we know that one is correct. And the relationship between x and y appears to be linear and negative. So this time around, it is negative. So that one is also correct. So we didn't need to work out the coefficient of determination. So again, they will structure it so that you will eliminate questions or options before you actually need to work out that whole answer of coefficient of determination. So if they wanted you to work out coefficient of determination, they will probably include R in there as well, so that you can say, well, determination is R square, and you can work out R square. So they will not, again, just give you that limited information and not have that for you. Okay, so let's look at other questions. So here is, and there is the the options that was given. So let me just crop again. Okay, so okay, cool. So let's look at this. Okay, so they tell us there is this magazine being published. The executive editor of a company wants to know whether readership preferences for the four magazines, Beat, Youth, Grow, the is independent of gender. A survey amongst 200 teenagers is carried out. The following contingency table is obtained. Which one is incorrect? Okay, so that's what they're looking for, incorrect. Okay, the expected value for cell youth and girls. Okay, so let's quickly, for youth, it was added 12 plus 26 is that 58. Then girls is 18 plus 12 is 50, plus 20 is 50, plus 28, so that is the 78. So to work out the expected is, and let's put it here, is 38 times 78 divided by the total 200. The 58 times 78 divided by 200 gives us 14,82, 14,82, correct. The null hypothesis states that gender and magazine preference are independent. Null hypothesis is always independent, correct. Alternative is always dependent, correct. Degrees of freedom is free. So question 4, it's row minus 1, column minus 1. So rows are 2 minus 1 is 1. Columns are 4. 4 minus 1 is 3. So 1 times 3 is 3. That is correct. Okay, and then chi-square distribution symmetrical. That is incorrect, but let's quickly show it so that you guys can see as well. So it's not just, so here you can see, so that is when something is symmetrical. Here you can definitely see the chi-square is not symmetrical, because if it was symmetrical, it would have been something like that. Okay, so definitely a chi-square is not symmetrical. Okay, so that was with this one, the one that was the incorrect one. And we could see now out of that table even that it is not symmetrical. Okay, so let's look at, I think we wanted to look here at which question? Maybe both. So let's just duplicate. We can look at both. So let's first do question 20. Let's see what we have, and then Okay, so question 20. For a sample of 12 items, so we've got n is equal to 12, from a normal distributed population for which the standard deviation is. So that means standard deviation is known. The sample mean is 250. At the 5% level of significance, test mean equal to 220 and mean bigger than 220. Calculate the t-stat. Okay, so t-stat is the z. We've got x minus the mean divided by standard deviation over n, or the square root of n. So that is 220. Okay, so already again, here we see the top part is going to be negative. So 220 minus 250 is, sorry, minus 10. So if I go to answers, that's the only one that is negative. Okay, but let's quickly work it out as well. So 17 divided by the square root of 12, that is 4.9075. So minus 10 divided by 4.9075, and we get the answer of minus 2,04. Okay, so again, nearly we could have looked at this from the beginning and said, well, it is going to be a negative number. So if we look at the answers, the only negative one is option 5. But then if we work it out, we can also see it is 0,204. Okay, so that is again Z, but this is with hypothesis testing. So this was study unit, was it 9? Okay, so let's do question 21, so that we can also just make sure that we cover that, because this is a different type of question. So in here, they ask us a random sample of 10 observations was drawn from a normally distributed population. The data values were 6447. Okay. A person tested the hypothesis of x bigger or equal to 6 versus that, and scribbled down his calculations. When his friend came along and quickly wanted to copy his work, he did not read properly and wrote down the following. Okay, which one of following above statements is correct? Sure, okay. So sample mean, we will need to work out with that. So we need to say sample mean is the sum of the x's divided by n. So let's see, it is 6 plus 4 plus 4 plus 7 plus 5 plus 5 plus 4 plus 5 plus 6 plus 4. Okay, so I get that as 50. 50 divided by 10 is equal to 5. Okay, so incorrect. Yes, okay, the sample variance is equal to 1. Okay, that one, not sure how to work it out if we just have this and without going the next step. So rejection region. Okay, so here we need to go to the T table. It's interesting. That so is on the T table is that n or n minus 1. So we're looking at the rejection region is T and they say minus. Okay, because they want us to look at that. So let's just check T 0,05, but that must be 9. So let's just, degrees of freedom is 9 because it's 10 minus 1. So T 0,05 and 9. So 9 and 0,05. 9, 0,05, 1,8331, 1,833. And let's just quickly draw that. So I'm going to just do it exactly the same as, but your x is, or your mean is bigger or equal to 6, so it would have been so it would have been 5 minus 6, so that is negative. So we are going to look at the negative table. So that is going to be our rejection area. Okay, so that seems correct. I'm just worried about that. If that should not have shown 9 because that's the degrees of freedom. But let's just look at the others. The T-stat is T equal to 3. So that is also wrong because it will be negative because 5 minus 6 is going to be negative. So at the top, doesn't matter what standard deviation is, we already know at the top it's going to be minus 1. So the conclusion is to reject the null hypothesis because the T-stat minus 3 is smaller. So let's quickly see if we look at that component. I just quickly want to get to my notes on that again, just to see that with the p-value, because this one we're not talking p-value, but which one do we reject? So if a T stat, so let me just write this down again. If your T is bigger than critical, we reject, so, and that is a positive of that. So T here is bigger, so we do reject the null hypothesis. Okay, so in this instance, we will reject. The conclusion is to reject the null hypothesis. Okay, so that is also correct. So what I'm thinking with this one is, like I said, that should not be 10. It should be 9 because we want the degrees of freedom. We don't want n, we want the degrees of freedom. So that is why that one is also incorrect. So that's a small thing nearly, because the rest would have been correct. That one is also then incorrect. So we actually, once again, did not need to work out your variance. What we had here was already the correct one. So that again is quite interesting. That's a small thing. That's why I said I'm worried about this one, because everything else is correct, but that small thing could, yeah, I could very easily, one can make that mistake in the exam where you think all of that is correct, but actually what they need to show there is your degrees of freedom and not n. So all they need to say 10 minus 1. That's a very small thing to really watch out for in the exam. That is not really great, but again, we did not need to work out some of the other information for this one. Okay, another one that we need to look at, the chi-square. Let's see what information. Oh no, this is not chi-square, this is probability. It looks like chi-square, but it is actually probability. An insurance broker is interested in knowing the occupations and gender of the residents of a small town. After a survey, he found the information shown in the summary table. Okay, so here we have 3 occupations, 2 genders. So then they ask us, determine the probability that a person picked at random from this town is a business owner, I assume. Okay, so they did not tell us how many people, so we need to get the total, and then we know that the total of business owners is 20, so 20 divided by how many people are in this town, that is your probability that we will pick a business owner. So 20 plus 46 is 66. 18 plus 6 is 24. So that looks like 110. So let's see. 20 divided by 110. 0.2 divided by, not 0.2. 20 divided by 1. 110 is 0.1818. 18, and that is option 1. Okay, if I ask farmer, it would have been 24 divided by 110. Okay, at least there's not the option. If I ask teacher, it would have been 66 divided by 110, 0.6. What else could we get here? That if I ask male business owner, it will just be 12 divided by 20. If I 110, if I wanted, given that there's a business owner, what's the probability of being male, then it is 12 divided by 20. Okay, so this one was actually probability, not chi-square. I just saw the table and thought they want chi-square. Okay, so then we're looking at that same information, refer to okay, and then they said, look at that information, determine the probability that a person picked at random from this town is not a farmer. Okay, so there's 24 farmers, so not a farmer is 110 minus 24. That is not a farmer. 110 minus 24, which is 86 out of 110. That is 0.7818. 0.7818. So not being a farmer, so the proper, or there's 24 farmers, so not a farmer is 110 minus 24, which gives us 86. So 86 divided by 110 will give us a 0.7818. Okay, so another probability, and nearly looking at the complement question. So here's another one. So obviously a lot of questions around insurance. Okay, so let's see. Hopefully this one will work out. So car insurance broker found that the number of policies sales follows a Poisson distribution, average of 3 cars per week. So average of 3. Calculate the probability in a given week you will sell at least 1. So at least 1 is 1 or more. And so again, the easiest will be to say 1 minus the probability of 0. And let's hope this time the numbers work out. So lambda is equal to 3 because that's the average. So average, the 0 is 0.0498. 0498, but it is 1 minus 0.0498, which is equal to 0.9502, which is option 5. Okay, so this one definitely worked out. Poisson distribution, we're looking at average, so lambda is equal to 3, and then want to know at least 1. So minimum one, so one and more. So that is how we will get to that answer. Okay, so let's look at another one. So now we go back to confidence intervals. Okay, so let's look at this one. Let's see what information they give us. A questionnaire was sent out to students of a certain college to find out who is responsible for paying their fees. The researcher found out that 50 out of 100 students pay their own fees. Okay, create a 90% confidence interval for proportion. Okay, so now again, it is the proportion formula. Okay, so now we can, when we see 90%, we know Z is equal to 1,645. So again, that is in your study guide as well, where they, I think it's in study unit 7, where they have that table of 90%, 95%, and 99%. So Z is 1,645. The pi, or the proportion, is 50 divided by 100. So that is 0,3. So we have 0.3 plus minus 1,645 times, and now it is 0.3. 1 minus 0,3 is 0,7 divided by 100. Let's just look at that. 0.3 times 0.7 divided by 100 is 0,0021. Square root of that, 0,0458. If I times that by 1,645, I get that we need to say 0.3 plus minus 0,0754. Okay, so that is going to be the closest. Wonder why it is rounded off like that. So that plus 0.3 is, the top one is 0,3754, and the bottom one is 0,2246. So somewhere there's a bit of rounding off in mine, but it is option 3 that we are looking for. Okay, so this was again confidence intervals with the proportion. Okay, another confidence interval. This time it looks like mean, so we need to just check, is this a proportion, or is it, sorry, not proportion, standard deviation known or unknown? So let's see. Delise kept careful records of the fuel efficiency of a car. After filling her car tank 20 times, she found that the tank covered 600 kilometers on average with a sample standard. So that means population is unknown. which means that we are working with the t. Okay, so that means we will still use your mean, but then it's plus minus t 0,05 divided by 2, and your degrees of freedom is 20 minus 1 is 19, and then still standard deviation divided by the n. So we've got the average is 600 plus minus that we're now going to look out for times standard deviation was 50 divided by square root of 20. Okay, so let's look at t. 0.5 divided by 2 is, that is equal to 0,025. So let's look at t. So we need to go back. Degrees of freedom was, I think, 19. Degrees of freedom 19, 0,025. 19, 0,025, so 2,093, 2,093. So let's quickly work that component out. So 600 plus minus, so 50 divided by square root of 20. That is 11.18. I hope that is correct. Times 2.093. I get 600 plus minus 23.4. So let me just work this out again, because there's nowhere 23. So let's just work this out again. 50 divided by the square root of 20. I get 11.18, 0,025 and 19, which is 19, 0,025, that is 0,09, 0,093, 0,093. Okay, so that times 2.093. Okay, this is what I get, so I don't get one of those answers. Okay, so I would get 623.4. God, 20 times. Found a tank on average of 50. Okay, this is, let me just check something. I just want to check because Yeah, I'm not getting that. Hmm. Okay, so again, it would be interesting if you guys have an answer for this one or worked something like this out, what you got, because again, if I look at these numbers, I don't get that one. Okay, so I don't know which one is correct, but I don't get any of them. So that is not great. We know it won't be this one. So that one you can nearly eliminate. If you add the two together and divide by 2, you should get 600. So yeah, option 5 is just incorrect. But this is again worrisome why this doesn't get to that answer or one of these answers. Okay, I'll check this out again because I am worried. Let's quickly check. Okay, so if that was 20, but it should not. Let's hope it is not, because that is just wrong. So we quickly just 2.086. Also not, that's also 23.24. Okay. I'll check this out as well because again, not getting any of these answers, so would just be important. So yeah, because you can't go with that one because so let me just make 100% sure again what is happening here. Okay, question 19 or 20, hypothesis testing that we're working with. So let's see what they give us. A sample of 200 observations shows that there are 36 successes. We want to test at the 1% significance level if a true proportion successes in the sample is less than. Okay, so that is correct. So if that is less than, the alternative or the null hypothesis is correct. So that is correct. We're looking for the incorrect one. P-value, the value of P is 0, okay. So that is the 36 divided by 200 and not the p-value. So that's the p as in the proportion. So that is 36 divided by 200, which is 0.18. Standard error of this test. So standard error is, remember, if we look at proportion, so that will be our standard error. So that is 0.24. 1 minus 0.24 is 0.76. That divided by 200. And that's square root. So let's again hope So 0.24 times 0.76. Yeah, I already made a mistake. 0.24 times 0.76 divided by 200. The square root of that, 0.0302. Correct, correct. Still looking for incorrect one. Okay, so the t-stat we'll need to work out. So we've got at least that standard deviation already. So the t-stat, remember, is that divided by standard error. So it is the 0, okay, now I just need to make 100% sure. And again, you guys can just check in your tables or in your study guide as well, that I am now using the correct method. So it is P minus that. Okay, so already now we can see the t-stat should be negative and not positive. So 0.18 minus 0.26 is minus 0.08, and that divided by 0.0302. Oh, okay, that is even. Okay, that must be 0.24 and not 6, but let's just do that again. 0.18 minus 0.24 divided by 0.0302, 1 comma negative 1,99. And so that is, it's not positive, it's negative, and then that one is also correct. Okay, so again, one could, but you still needed to work through to get to that one. But then if we follow the process, we see that the t-stat is negative, and then negative is not, we've got it in the answers as positive. So that is the one that we are looking for to say, okay, that is the incorrect one. Okay, so we've still got some time. Let's just look at more questions. And please remember, you have still can send me other questions that you have. Okay, so let's see. This one looks at a recent survey predicted that a certain political party would receive exactly 60% of a country's vote. A local survey of 450 people was done and found 300 people would vote for the political party. For testing the original claim at a 5% level of significant, compute the test statistic. Okay, so let's quickly see. Okay, so we again working with proportions. Sure. Lots of proportions in this one. So if you guys have others, just let me know. So 300 divided by 450. So 300 divided by 450 is 0.6667. Okay, so then as this one, we just need to make sure. So what is the population? What is the sample? So that is the 0.6. That is 0.6667. So this time around, it will be a positive. So now again, 0.6. Then 1 minus 0.6 is 0.4. And that divided by I think I'm now wonder now if I'm doing this right, the right way around. 0.6 times 0.4 divided by 450 square root. Okay, am I doing it the right way around? That now is my worry. Recent survey predicted that a certain political party would receive 60% of the country's vote. A local study of 450 people was done and found that 300 people would vote for the political party. For testing the original claim at the 5% level. Okay, so I would have said that is my null hypothesis. So that would have been, I would have said that is exactly the 0.6 would have been, well, sorry, not equal to. Okay, so then it is that minus that. So 0.6667 minus 0.6. And if anybody has anything different, please shout. And then let's work out that standard error. 0.6 times 0.4 divided by 450. The root of that is, I get 0.0231. So that divided by that, 0.0667. I get 2.88. So let's just worried that I think I'm using the wrong one at the bottom. Quickly Just make 100% sure. Times 0.066. Yeah. Okay, so we need to work out here. So the set that we're working out, so that is actually fine. We're working out the Z, but what we need to do here is one minus 0.6667, because I was worried about the sample that we're now dividing by 450, but that at that had no connection to that. It has a connection with the 300. Okay, and if you work that out, our answer will be 3.03. Okay, so so this one was a bit a tricky one that we needed to work out. Even let me just make 100% but for this one as well. I'm wondering between those two. That feels like the null hypothesis. I will just make 100% sure again that this feels like the correct way. Okay, so let's do one more. Okay, so it's based on this. So now we can actually check if some of our thinking was correct. Let's hope it is referred to question information, state the hypothesis, and state whether the test is lower, upper, or two-tail. Okay, so here we have the information. There's the one, there's the other one, and there's the two-tail. So it is option 3. So now we know at least that what we did is also correct. Let's just check the others. So we're not working with a mean. This one also not, because they said receive exactly. So there wasn't anywhere in those sentence more than, less than, or anything like that. Again, it was set exactly, so it needs to be two-tail. And again, here we're not working with a mean. Okay, so at least we know that component is correct. So then that is correct, that is correct. So we are now sure that it is actually option 4. Okay, so we don't need to, it's not very nice structured, but that is at least what we now just made 100% sure of the previous one. Okay, so then let's end off with question 23. And then we've got a few for tomorrow, and then also you can still send me other ones on my WhatsApp or on the WhatsApp group that I will add to another to some of those questions that we can work through tomorrow. So the last one. So chi-square that we're working here with. Here they ask us the study on the mode of transport that workers use to commute to work and the associated distance. So we've got one that says 0 to 10, 10 to 50, and then we have the information. So they just ask us for testing at 1% level of significance or significance level, what is the critical value? Okay, so we need to go to our table, critical value, so degrees of freedom, row -1, column -1, and we don't include totals, so no totals included. So we've got 2 rows, 2 minus 1, columns 3. So degrees of freedom is 1 times 2, okay, which is 2. If we added the total, it would have been 2 times 3. So let's just see if we get the answer for degrees of freedom of 2 versus degrees of freedom of 6, if there is actually also a number. And then at 1% level, so that is 0, 0.01. Okay, 0, 0.01 and 2. So let's go to the table. Just want to see where we need to go to. Okay, 2, 0, 0.01. So it is 4,605. Let's hope. Oi, am I at the right table? Yeah, 2, 0, 0.01, not 0, 0.1. Easily can make that mistake. 9,21. 9,21. Thank goodness there wasn't now that one for me, because that was just a silly mistake that one can easily make. I just want to check at the 6. So 16,812. Okay, so at least there wasn't a 16,812 that one could have gotten wrong if you have added that. So luckily not, but I could very easily have made this mistake with actually going for 0.1 and not 0.01. Very easily one could make that mistake. Luckily, there wasn't an answer for me, but actually glad that I now showed you how to not make that mistake in the exam. Okay, cool, everyone. So that's it for tonight. I will download the recording. I will send you this presentation all on the WhatsApp group, so that you have it. And then tomorrow night we will just finish off. And if there's any other questions, please WhatsApp me with those questions, and then we can do that just as a final round off tomorrow, before you guys write on Saturday. Okay, good luck for the last prep and everything, but we will see again tomorrow afternoon at 5 o'clock. I will again share the link on the WhatsApp group, so that you have it, and then we will see again tomorrow afternoon. Have a good evening, everyone. And once again,